I talked about the addition rule in the last movie. Now I'm going to talk about the multiplication rule. The multiplication rule applies whenever we have compound events that are separated by an and. For example, if we had the probability of A and B, the probability would equal the probability of A times the probability of B. Now, just like the addition rule, there are two versions of the multiplication rule. One applies if A and B are independent events. In other words, if A occurs, it does not affect the probability that B occurs. They can both happen at the same time, but the occurrence of A does not affect the probability of the occurrence of B. If the events are not independent but are dependent, we have a slightly different version of the multiplication rule. The probability of A and B equals the probability of A times the probability of B, given that A has already occurred. In other words, this little symbol here means the probability of B given that A has already occurred. Remember, if they're dependent, then the probability of B does depend on the probability of A. Let's look at an example. Suppose that we flip a coin and roll a die. Find the probability that we get heads and a 5. So we always want to write out our probability statement. In this case, it would be P of H and 5. Well, when we roll a die and flip a coin, these are independent events. In other words, whatever happens with the coin will not affect what happens on the die. Therefore, we can simply multiply these together. Probability of H times probability of 5. Probability of H is 1 out of 2. 5 is 1 out of 6 for a probability grand total of 1/12. Alright, well, what if the events are dependent? Suppose that we have a bucket with 10 red and 7 yellow marbles in it. Also, suppose that we draw 2 marbles out without replacement. In other words, when we draw a marble out, we don't put it back. Find the probability of getting a yellow, getting a red and then a yellow. So write that probability of R and Y. Now we have to think, are these independent or dependent? Well, if you were to just reach into the bucket and grab a yellow, the probability of choosing a yellow is 7 out of 17. Now, if you'd already chosen a red, that probability would change. If you'd already chosen a red, the probability of getting a yellow would be 7 out of 16. Therefore, these events are dependent. So we'll use the second version of the multiplication rule. And that'll give us probability of R times the probability of Y, given that R has already occurred. Probability of R is 10 out of 17. The probability of a yellow, given that a red has occurred, is 7 out of 16. Alright, and we'd work this out and get the answer. I don't have my calculator with me right now, and so I'm not going to do it. Alright, so that's the multiplication rule. Let me back up for one moment and just look at probability in general. Whenever you're working probability problems, there's a few important things to remember. First of all, think of the set of all possible outcomes from the probability experiment. What does that look like? What's in that set? When you're thinking of compound events, think of all the mutually exclusive ways the event can occur. That's really important. Always write out a probability statement. Don't start by just writing down numbers. Now, once you have your probability statement and you break it down using the addition rule or the multiplication rule, you can substitute numbers into the statement and find out the final probability. One last thing I want to do here is just give you another view of the difference between mutually exclusive and independent. Remember, mutually exclusive is used for compound events that involve an OR. So mutually exclusive is used for compound events using OR. The question with mutually exclusive is whether the events can occur at the same time. Alright? For independent events, we use that for compound events that use AND. The question is whether the events that can occur at the same time are actually independent of each other. Independent means that if one happens, it does not affect the probability that the other happens.